Hey everybody, today we're going to talk about how to go through and build our own customized mech or interactive toy for our homebrew pinball machine. My theme is Led Zeppelin, so if you remember me from the other videos talking about this, one of the first ideas I had was for a motorized, mechanical, magnetic stairway, or staircase, right? Stairway to heaven. I think it's going to be a lot of fun. It's going to be this engineering challenge. This is kind of a shot of the current prototype. It's not totally proven yet. I haven't actually got it hooked up and working through the software or anything, but mechanically I think it's sound. I've gone through a few iterations. I'm going to show you all of that, but one of the first things before I jump into that I wanted to share with you is I've gone through and I've made a goal for a date for completion. These projects I've heard from everybody, and I'm understanding already, can kind of drag on forever, right? I think one of the running jokes in the homebrew kind of community is it's not, have you started building your own first pinball machine? Oh, how many pinball machines have you started building? How many machines have you actually finished? Nobody finishes a pinball machine. Well, okay, people do. Lots of people do. But it's also one of these things that people can just kind of go on and on working on forever. I don't want it to last forever. I want to hurry and get this thing done. So there's a couple of pinball expos that typically happen out here in the West. I'm outside Salt Lake City. It is now July 2021. I am setting myself a goal of having my machine in a playable state, mechanically complete, software at some level of being able to be played with some basic audio, some sort of basic artwork, I'm hoping, but it might still be white wood. We'll see. By May of 2022. That's when typically there's an expo that typically happens in May every year, the Rocky Mtn Pinball Showdown out in Denver, Colorado. There's also one in the Golden State Pinball Festival out in Lodi, California. Those both typically happen around May, late spring. I haven't seen on their websites what they've announced for 2022. I'm hoping that at least one of those will still be happening and I can load it up and drive it out there and we can play test it. And if you guys are nearby, I'd love to have you come by and take a look. So that's my goal. It gives us about 10 months, which realistically means we got about 9 months because that last month is going to be just butting up the last little things, I'm sure. Anyway, so that's my goal. We'll see if I can make it. You can let me know in the comments whether you think I'm just completely up in the night. Maybe there's no way, but I think it's possible. Okay, that's the goal anyway. All right, so back to the staircase. So any mechanical toy or big mech or interactive thing you want to have in your pinball machine, almost always going to start from some sort of just concept. For me, again, I said that's more paper and pencil. I do get into Fusion 360 and do things, but I'm not proficient enough, I guess, in Fusion 360 to where I can just be flying off, just creating things left and right really, really fast. So for me, I don't typically get onto my computer into Fusion 360 until I've got a pretty solid idea already sketched out in my mind and on paper of what I want. And then I can take that and I can translate it into Fusion and actually build something up. So for me, I started with this sketch, which I'll put up here on the screen for you. So again, this is kind of the rough layout. Not exactly to scale, really at all, the more I've been putting together my white wood. But you can see here kind of in the middle, these horizontal lines. It's kind of the central element of the stair. And the thing I like about this mech is I really like, in a lot of pinball machines, fun ways to stage balls for multi-ball. Some games just have kind of what they call a virtual lock. You'll hit a shot or it'll go somewhere and the game will recognize that, hey, you've locked a ball, but then the ball maybe gets kicked back out or continues rolling around. Or I like games that actually have a physical place to go and trap and hold the ball. Even better if you can see it, it's sitting there waiting for you. Then you get a second one. Okay, these are waiting for you. You're so close, get that multi-ball, and then you get to have some way to watch them kind of come loose onto the playfield. Now there's other ways to do it that are just fine too, but I like that. So I thought the staircase, what if each step of the staircase could have a magnet and hold a ball, and then you hit a switch, and you advance the staircase up a step, and then you add a second ball to the next step, and then so on and so forth until you get a full staircase of, 4, maybe 5 balls tall, right? And now you've got this staircase that's loaded with balls, staring you in the face, saying, start multi-ball, right? And then you start the multi-ball, and then the staircase just continues to advance up and up and up, and at the top, they spill onto the playfield. I've decided that I think currently I'm going to have them go onto an upper playfield, because I want to try to build an upper playfield, because we're just trying to do everything in this pinball machine. If it ends up being a stupid upper playfield, we can take it out. We'll wait and see how it goes, and yeah, we'll find out if it's fun or not. Some upper playfields are a lot of fun. So for now, I'm going to try to have them all kind of dump up onto an upper playfield. It's going to be a small area, a lot of balls. It's going to be kind of crazy chaotic. It might not work. We'll see. But there'll be some shots up there. I'm still figuring that part out. So again, the idea, though, is that each step can hold a ball, and it can advance. And yeah, I think it's going to be a lot of fun. So So you'll see there kind of the prototype again, right, that I had. So let's jump over into another part of my sketch I'll bring up on the screen. And this shows a little bit more exactly kind of in my mind how I started envisioning this happening. So this top part up here, you're going to see, I even list out, 12 steps. I went through and kind of counted. I'm like, all right, each one of these steps is basically going to be kind of like a triangle, like a wedge, right? Again, the thing I was trying to model it off of was like a real world escalator. Okay, how does an escalator work? Well, they're more complex. There's a little more going on, like the grooves and things, but still the basic principle, right? You've got some sort of like a rotational point, at the top, and then another rotational point at the bottom. You got these two rotational points that are with gears or something turning this conveyor of connected stairs, right? It's going to loop around up and out of the playfield and back down. And there might need to be some sort of like a track in the middle to make sure that, the stairs don't sag under the way of the ball. Actually, I don't think we're going to need that, but that was a concern early on. So this sketch here, you can see I've kind of, right, 1, 2, 3, 4, and the fifth ball is like flipping up on the top. And then I've got this upper playfield is this flat angle or flat plane, and I've got kind of this like little slope to it. And that's because I need something to kind of help scrape the ball off the step. Okay, and we'll come back to that when I show you exactly how I built the step. It's not going to be able to be a controllable magnet that holds and then releases the ball on command just because of space. But that's kind of basically what I'm envisioning, right? The ball is going to go up and then be released on the upper playfield. Here in the middle is kind of my ugly sketches of each step is going to need to be basically kind of like this triangle wedge, right? A top surface, top of the step, and then like the front side of the step. And the back is going to have this angle, and there's going to need to even be like this little groove you can see I've got in there cut, so the gear has something to grab on the steps. I don't know if I'm going to need like multiple gears. Right now I have a gear that just has like 4 teeth. I think that's going to be enough, kind of like one per step that goes around. Seems to be working okay. We'll see how that holds up in actual gameplay and moving things around. But okay, that's kind of the basic idea. So I came up with that. I'm like, okay, I kind of drew one, repeated it around kind of in that square. Okay, how big does my teeth need to be for my gears? That's kind of what I got in my head, and it seemed like it made a lot of sense. So from there, let's go to the computer. Okay, I'll show you what I've got here in Fusion 360. So here's what I ended up modeling. Here's kind of my basic step. Okay, this is the front, and here's the sides. Again, it's kind of a triangle right on top, and I've got it such that these pieces, they'll all be able to kind of interconnect. And one of the things I like about Fusion 360 is you can go through and you can duplicate your bodies or your models. And so I went through and I duplicated and then rotated these around. So I got 4. So again, it kind of looks like that sketch I had in my book, right? So okay, these 4 all kind of fit in, right? You can see how this front part kind of fits in between these legs, right? So, right, again, how that goes. So if you don't know Fusion 360 and you want me to talk about that, let me know. There's lots of videos out there already kind of giving you the basics of Fusion 360. That's how I got into it and got it figured out. It's really not that difficult to learn for some basic, just basic inorganic modeling. You're just kind of pushing and pulling some surfaces and rounding some edges. And let me know if you want me to do a video just around that, and I can kind of walk you through specifically how I created some of these models and teach you the basics. There's a few tricks. I don't pretend to know everything about Fusion 360 at all. There's a lot in this program, but the basic stuff, how to create a model, how to export it out to an STL file, which is going to be used in a 3D printer. Again, we'll get to that. But so I came up with this in here, right? So I kind of have these 4 items, or these four steps. And then I went through and said, okay, I need to go through and create a gear, an axle, right? That can then turn these. And again, I went through and I brought in all my steps. And so I was able to make sure that this fit, okay? And one of the things I like about Fusion 360, like and don't like, is you can go through and change the opacity of each item, so you can kind of see inside it, and you can see how well these, something else is fitting inside another item. What I don't like is I have to do each body independently. I can't multi-select. That's kind of a pain in the butt. Should fix that, Autodesk. Okay, but this lets you go through and see, okay, here's kind of those cutouts I have inside there, right, for where those gears are going to go. Are those going to fit around things? I feel like they will. Okay, we can make sure they do, right? And then the other thing we need to go through and create is we need to have some sort of a motor to control this. And so we're going to have a stepper motor. So I needed some sort of a bracket that could basically, hold the stepper motor, which is what this one will do here. Okay, it's got little grooves cut out based on the actual stepper motor. I'll show you the stepper motor in a minute, and you'll see how that fits in. Sorry, these camera controls are sometimes a little wonky in Fusion 360. Okay, and then I needed some sort of like a plate, right, that allow me to actually like, you know, screw this underneath the play field, okay, on top. And once we had that, then it's just a matter again of kind of, okay, do all these things actually line up together? So we needed to make a gear for the motor. That's kind of one end's flat for the end of the shaft of the motor. It's got this recessed area. Again, I'll explain that out here in person, but these are the teeth for it. And then again, does this all fit, you know, inside the stairs? Looks like it does. So we've got this final assembly now, okay? And we could go through and then export each one of these as its own little piece and go through and take it over to the 3D printer and then print them out. And then, we've got our working staircase, right? Easy peasy. Make it seem so easy, Steve, like you just model some things, no big deal. Feels like it'd take me forever to do that. Honestly, guys, Fusion 360 is really, really not that difficult, okay? If you've never done any sort of 3D modeling before, it takes a minute to get your head around it. It does, a little bit, but seriously, just watch some videos. There's a lot of sucky videos out there, really boring, dry videos. They're like hour long. They're like for professionals. Try to find some videos of just kind of some more average Joes like ourselves who are playing around, learning 360 for the first time, you know, 360 for noobs, 101, those type of things. If you don't find anything, let me know. I'm happy to create one, take, you know, a half hour or so and kind of show you some of the basics that I understand and how I use them. But it's doable, okay? It is totally doable. It's a step. And you don't have to do this, right? You might be able to come up with mechs and ideas and things that don't require 3D printing. I love my 3D printer though, because you can make literally anything, okay? So I did all this with 3D printing. So to that end though, let me go through and kind of, you know, take you behind the curtain here for the Wizard of Oz, so you're not getting too impressed with what I did, because I had some screw ups along the way. Let's go see. All right, here we are. It's a lot of plastic. So you remember I said I figured out it's 12 steps per staircase, right? For an entire staircase, it's going to take 12 steps. So it's a lot of plastic I went through, but I think it's worth it. I think we came up with something really good here at the end. Obviously, you can see some of the core parts, right? Obviously, we had steps. We had lots of different steps that I came up with, and I had here kind of some of the core ones, right? I had like this really big one initially, fat guy, kind of worked, bigger guy. This is one where I actually started putting some of the grooves in. Yeah, and then this is the size we actually ended up with. So one of the things that I did very poorly, I went through and I said, you know what? This is a good size stair for a ball, okay? All right, just holds it well. I don't have a very good background there, but it's like, this is a good size for a ball, okay? It feels like it's a good size, doesn't feel super puny. I think it's gonna be great. Went through, built one up, got 12 pieces of this all together, all with little metal axles I have going inside of these, and thought everything was great. Then I went through and put it into the play field, and it was way too big. It's like, oh, I didn't really go through and calculate the height fully. I mean, I kind of did in my head. No. Measure twice, cut once, right? Don't measure twice, print once is a rule I should have followed. So I went through and I printed this all out, and it was so tall and so long, it was taking up almost the entire upper third of my play field. It was going to be too tall. Things were going to be hitting the glass. There wouldn't be any room for an upper play field. And it was just taking up so much, I didn't have room for the other shots I wanted. So I was like, okay, I gotta get smaller. So I got down to this size. It's a little bit narrower, still kind of wide. Still, I think it has decent width, but it's not quite as deep. Each step isn't quite as deep, but it's still enough to hold a ball. Gone through and tested it, and it works good. This saved me a couple inches both directions. So now I can actually fit in the other shots I wanted, the diverters and things we had before. The ball can still have room for an orbit all the way around behind it. Anyway, it works out way better. But of course, I didn't learn that until I'd already printed out a couple of sets of stairs. Oh well. I also went through, as you can see, and iterated a lot on I need to come up with some sort of different, like stands. Again, at first the stair was going to be really tall, so these really big supports. Then after I cut it down, look at that. That's like so much smaller of a support now, right? For the top side, for the height. Yeah, saved ourselves a couple inches there easy. That was nice. Played around with the different housings for the stepper motor. So let's talk stepper motor for a little bit. So again, we want this to be a mechanically controlled staircase, right? So we need to have some sort of a motor to power this. And I decided to go with a stepper motor. They're very precise. I found one that's a small enough form factor that I think is going to work, not this giant stepper motor like my 3D printer has that would not fit anywhere. Some people are using servos, and they've said they've had a lot of good success with them. I tried using some servos for a science experiment with one of my kids a few years ago, and I just had a hard time getting a precise enough movement, so I decided just to use a servo. I found this little servo. So my list, I want to say, was around 20 bucks. The little controller card for it was 30, so that's reasonable, right? It's kind of one of our core toys for the game. So this is just this small servo here. Again, I got a link for it, but the form factor is great. I haven't actually got it hooked up yet. The wire's never been plugged in, so we've got to actually make sure we can get it communicating. There'll be a later video to actually go through and talk about how to use servo motors. But yeah, that little notch, if you remember from before, is because this has a little bit of a bump for where the connector goes in for the wires. So that just slides in nice and snug. Okay, then we've got the axle. It's flat on one side. That way you can put something around it. It's got this little guy here. It fastens on the end to hold things in place. So this, I started out again with some larger teeth when I had larger steps. Then I went through and worked on some thinner teeth that were beveled because I had trouble really always engaging with the stair correctly and not binding. So we started to kind of bevel some of these edges until that one was a little too skinny, had too much play, till we ended up with where we are today. And so yeah, so that flat part, I'm not sure how well you can see this. I might zoom in if I have to. Hopefully you can see this well, but that just slides on. This little guy goes in. It's got a little notch there, so we can reach the little Allen key, the little screw. That then will hold it in place. I feel like I'm starting to strip that a little bit. Okay, and then that's our bottom gear, okay, to move the staircase. This will get anchored up underneath the play field, hold it in place. And then the actual staircase, here's the current one you can see. This will go inside, okay, and ta-da. This part will be under the play field. Get a different angle here, right? Okay. The metal here is going to be a metal ball guide for the inside of that horseshoe, if you remember. Okay, so that's about the bottom of it, the plane of it there. Okay, I'm not sure how well you can see this. My background's not great. I think about how I needed to be up against a wall. Anyways, hope that gives you an idea. Okay, and as this goes through and turns, see, even just kind of do it with my finger, we can get it moving. Okay, it looks like it's binding, but trust me, this is all screwed in place. It actually moves pretty smooth. Okay, so that's our staircase. All right. So lots of iterations to get to where we are. Now, if you remember, I talked about magnets, and you know there's no way one of these magnets is going to be able to fit inside the stair here. It's just like, how do you make this work? Be controllable, have the wire switch, rotary. Yeah, that's an issue. So, yeah, that's an issue. So, how do we make that work? Well, neodymium magnets, am I saying that right? Neodymium, anyway, strong magnets, strong rare earth magnets. You can get these in lots of sizes and shapes. So I got some that are just in these round discs, okay? Nice and thin, okay, like a size of a nickel. And not sure how well you can see inside there. I modeled a little slot inside my stair so that this magnet, okay, can just be pushed inside. Right? And now, the staircase before would not pick up a ball, right? But now, there we go. It'll hold the ball just fine. Now, it's not super strong. I can, force it to let go. But it holds on fairly well. Okay? And we get one of those on each stair. It just needs to hold it, come up through, till it gets to the other side, and then it's going to have another piece of plastic. The plastic is going to come through and it's going to scrape it off, and that'll release it onto the upper play field. That's the plan. On my trial one, just manually, it seems to be working really well. So that's kind of where we've ended up. all right? Right now, it's manually working. The next step is to get the motor hooked up, the stepper motor, get it connected to the software and to power, see if it'll move on its own and actually work. Okay, so the very next video, though, is going to be all about going through and taking out all the cardboard that we had in there for prototyping ramps and shots, replacing it with metal guides like this. So I'll go through and talk about how I sourced the metal, how we're cutting it and shaping it. Still figuring some of that out. So yeah, pretty much you're caught up to where I'm actually at with my pinball machine. So from here on out, might be a lot less, it's going to be a lot less scripted. Hopefully we'll be able to make some good progress from week to week. We'll see how it goes, all right? Thanks for watching, everybody. Please like, subscribe, share this around with everybody else. And if you haven't started building your own pinball machine yet, why not? If I can do this, anybody can do this, okay? And there's so many people out there willing to help you. I'm part of a community. I'm just one guy. I'm the dumbest one in the group. I am mooching off everybody else from all their ideas and techniques, all right? But you can do the same, okay? We're all happy to share. It's a great community. I strongly encourage you, jump in, start making your own. Okay, guys? Until next time, have a great day. Bye-bye.